Good evening, everyone. My name is Cody. I am a software engineer at Joyent, and I am here today to talk to you about AWK. So how many people in this room have not used or are not really familiar with AWK? All right, some of you, cool. So what is AWK? AWK is a, AWK is a language and utility for generating reports and transforming data. So you write these programs that consist of pattern action pairs. So you write these patterns that say what lines of data you want to match, and then you write these actions that describe how you want to act on it. Do you just want to print the line? Do you want to print it in a certain way? Do you want to transform it? It supports various string operations, arithmetic operations, and user-defined functions. So here's an example. You can write these begin statements that say, at the beginning of my awk program, I want to print out this text. And at the end of my program, I want to print out this other text. And what we have here is on every line, I want to take the different columns, column 1, 2, 3, 4, and 5, and I want to wrap them in these XML tags. So this is a program that I had written several years ago for transforming a CSV of events into XML for a program I was using. The name is derived from its three authors, Alfred Aho, Peter Weinberger, and Brian Kernighan. And the language was at the time unique in several different ways. It was an interpreted language, which there weren't too many of. The only really interpreted language you had on Unix at the time was the shell. It has associative arrays. Before awk, the other languages that had associative arrays were mumps. If you're not familiar with mumps, there's an excellent daily WTF article on it. Commit, the first string manipulation language, and Snowball, its successor. Snowball is sort of an interesting language here because in many ways it's sort of a predecessor to awk. Snowball 4 was released almost a decade before, and it was an unstructured language, so it looked like much like assembly, and it allowed you to do some similar things, but much less elegantly. So to understand awk and the need that it fulfilled, you sort of need to understand what it was like to work with text in Unix at the time. So the year is 1969. And Ken Thompson begins writing ed1, the standard text editor. Ken was inspired by the QED editor, which he had written two implementations of previously, one for the compatible time-sharing system and the other for Multics. His implementations were unique in that they introduced regular expressions to the QED editor. Jumping forward several years, Doug McIlroy introduces pipes. And then, while working on a voice synthesizer, he finds himself constantly searching through Webster's dictionary. He's using the G command to find words that contain different combinations of letters. For example, UI matches fruit, matches fluid, and a bunch of other words where you pronounce UI in different ways. And he wants to find words that he can test out on his voice synthesizer. Unfortunately, using the G command in ed at the time results in multiple passes through the file. So it's painfully slow, and sometimes, well, the dictionary is too big for ed, and so he has to split it up into multiple files, which then he has to search through. McIlroy then goes to Thompson and says to Thompson that he would like to have a tool that works like the G command in ed, except it would just do a single pass over a file, an input stream or a specified file. So Thompson creates grep from ed's regex library. And McIlroy considers this an important point in Unix history because this is the beginning of the Unix tools philosophy. Thompson calls this the liberation of grep from ed. Later that year, Lee McMahon begins working on a grep utility. The idea was that it would work just like the grep command is the g/regular expression print of ed. Gress would be similar. It would match a regular expression and allow you to substitute the matching text with your own. As he starts working on this, though, he realizes that if he's going to make a grep command, he may also want to make a grep command, which would find patterns and delete lines. He might also want a grea command, which would find patterns and append lines. As he's thinking about this, he realizes that what he really wants is a streamable version of the ed editor that would allow him to manipulate streams and also manipulate content in pipelines. So in early 1974, he creates sed instead. These are the tools that were available in 1977. In 1977, working in Bell Labs, these are what you were able to use. As Aho, Weinberger, and Kernighan point out in the 7th edition manual for Unix, none of these support arithmetic operations, they don't support logical relations, and they don't support variables. So, as Aho is managing budgets, and as he's trying to track grades for students in a class that he was teaching at a nearby university, he realizes that he needs something better. He needs something that will allow him to produce these reports that he wants. So, talking with his next door neighbor, Brian Kernighan, he realizes that they both sort of want this tool, this language that would enable them to do these things. As Kernighan put it, they wanted to make it really easy to write very simple programs, tiny programs, where in your heart you know it ought to be just a line or two of code. And if the language just supported it, you could express what you wanted to do in just a few lines. Several years before this, 2 other important tools were created, YAK and Lex. These are key because they help start and spur the tradition in Unix of creating these little languages. For example, BC, an arbitrary precision calculator, and econ, a language for writing equations for trough. Using Lex and YAK, Kernighan and Aho are able to put together a grammar and determine what language they really want, what it's going to look like. Once they had something, they showed it to Weinberger, and excited by the idea, he runs off and creates the environment for this tool, for this language. It was rather successful. At the time, the only other interpreter language you could use inside a shell pipeline was a Thompson shell, or you could use the Bourne shell made a year before, or the PWB shell. So AWK really enabled people to do things in pipelines that they just weren't able to do previously. Aho recalls coming into the office one day to be confronted by a rather testy engineer from another division at Bell Labs. It turned out that the engineer had been writing a computer-aided design program that was several thousand lines of AWK. And he had spent the past 3 weeks hunting down a bug that turned out not to be in his CAD program, but to be in AWK itself. So thus, Aho took part in the great software developer tradition of being yelled at by your users for your bugs. Jumping forward many years, I arrive in my freshman fall at university. And I'm taking a class where we are implementing projects in MIPS assembly. And the TAs want to make sure that we are properly saving our callee saved registers. So they release a script that takes your MIPS assembly and surrounds your JAL instructions with assertions to make sure that you properly restore the registers. And also, they trash the temporary registers to make sure that you're not relying on them keeping their values across the JAL instruction. I was rather curious how the program worked. So I opened it up, and it turned out to be a script that was just one long awk program. At that moment, I realized that this was definitely an interesting, powerful tool that I needed to learn. But it wouldn't be for almost another year before I really got an opportunity to learn it and exercise my knowledge of it. So working as a teaching assistant, we had a lot of files that looked a lot like this. They contained the username for the student, and they contained how well they did on a problem or on a homework, and they were separated by tabs or commas. So this was perfect for awk. And so I needed to rearrange them. I could, instead of using cut, use awk. So before, it looked like that, and afterwards, it looked like that. But then I found that awk was useful for so much more. When I needed to append text to a column, instead of doing that to get an email address, I could instead do that. And while they're not too different, I find awk is much easier to remember. It's much easier to remember what it looks like. It's a language that's consistent on its own. You don't have to remember all the different delimiter flags for all the different Unix utilities. You don't need to remember that it's sometimes -k or it's sometimes well, that's columns, but for sort. But you don't need, awk's much more consistent, is what I'm driving at. It also enabled me to do things that I just wouldn't have done in the shell before. If I wanted to extract certain information or build a report, I would have just done it in a spreadsheet or done it in an editor. But awk allowed me to visualize the information that I wanted. So if you wanted to, say, find all the lines where the columns sum up to less than a certain number, you could do something like this. But this is much simpler. As time went on, I found myself able to use it for many other things. So when I needed to manage a Jabber chat room and I needed to set up the affiliations to let people in, I was able to take a list of all the usernames and generate the text to copy and paste into my client instead of typing it out again and again. Or when I was managing a private network that had a FreeBSD gateway, I was able to generate the PF rules to map ports on the gateway to ports on the private network without having to do it again and again and again. Fortunately, I meant to say this earlier, but years ago I set my history size to 1 million, which has made this a much easier presentation to prepare for. I'd recommend doing the same. Or when I needed to load a CSV into a MySQL database, I was able to generate the insert statements. As my needs grew, awk grew with me. So here, for example, I had a number of images that were sent to me, and I was told to make a gallery out of them. So I wanted to put 2 images per row, but I had an odd number of images for some of them. So using awk, I was able to generate the body of these web pages. So what we have is on the odd numbered rows, so starting at the first line, open up with the div tag. Then print out a link to the image and the image itself. And then on the even numbered lines, after we have printed out the second one, close the div. Then at the end of the file, if we end on an odd numbered line, then we need to print out the image that I have to line it up, the empty image. I was able to embed this into a shell script to traverse all of these directories and build the appropriate page in each one. I've also found that awk is really useful when you're working in the shell and you just quickly need to transform the information into valid input for the next command in the pipeline, or when you need to, say, split a file up into multiple files. So this is one thing that I haven't really found a cleaner way to do this. I think it's clean on its own. But if I want to split input up into multiple files, then you can use the file name. Say, like in this case, we have a command that's printing out a list of firewall rules. And the first column is the UID of the rule. Second column is who owns the firewall rule. And the third column is the rule itself. This takes care of splitting up the output into a file for each owner of every rule. So we print out the whole line into a file based on the name of the owner UID. I've also found that awk is excellent for when you need to sum information up. You could try to take the output and transform it into valid input for BC, or you could use awk to sum it up. It's especially useful if you have, say, multiple values you want to sum. So in this case, we can take the value based on the value in the first column. We can create a new associative array called sums, keyed on the value in the first column, and add the second value bit by bit. Because awk defaults to the value 0 for numbers, we don't have to do much work to initialize this. And at the end, we can iterate over the array and print out the key in the value. This is probably what I use it for the most, other than trying to access columns. Alka is very useful for if you just want to print out values where one line matches, where you match on a column. So if you want to find things in column 2 that match text true and print out the value in column 1, awk's there to help. And this is one that I've never needed, and I hope no one else here has. But the only true cross-POSIX system method for getting the Unix epoch is with awk. So the %s format character for date is not standardized. I'm not aware of a system that doesn't have it. I've been told that Mac OS X used to not have it. But this allows you to get it. So the trick here is that srand, when called with no arguments, changes the random number generator's seed to the current Unix epoch timestamp. And then when you invoke it again, it returns the previous seed. So calling it twice will give you on the second time the Unix epoch from when you first called it. Unfortunately, POSIX does not provide any other way to do this. But in case you ever find yourself in a dire situation, awk is there to help. Awk has had a wide influence. For example, Perl is very heavily influenced by awk. Using the -p flag, you can write Perl programs that can have begin blocks, end blocks, and all the other content will be run on every line. And at the end of an iteration, whatever the value of $_ is will be printed out. So you can write these short scripts in Perl that will iterate over every line and transform it into whatever you need. So I wrote a similar program, simple program that takes a list of emails and generates an XML file based on that. It's also influenced DTrace. So similarly, you have the begin action. And then we can, for those of you who haven't seen DTrace before, in DScript, you write the name of a probe that you want to match on the system. So we want to see new successful execs. And then we want to filter on things where the user ID is 1000. And if it matches, then we will run the action, and we'll print out the new process and the arguments to it. And at the very end, once we're done, we'll print exiting. It's also had awk's changed a lot over the years. So awk earlier, the one that was released in '77, is usually referred to as the old awk. It's rather buggy, and a lot of those were fixed in 1985. Then after that, user-defined functions were introduced. And POSIX ended up standardizing in 1991. And it's still maintained by Brian Kernighan. So you can go to his Princeton website today, and you can download the last release, which was in 2012, and run that locally. It's also in a lot of package managers. It's still used by Illumos, FreeBSD, NetBSD, OpenBSD, and OS X. So those of you with MacBooks in here, whenever you use awk, unless you type gawk and have that installed, you will be using Brian Kernighan's awk. 1 year after 1985, Paul Rubin wrote Gawk. But that was modeled on the old AWK. So in 1989, David Truman and Arnold Robbins rewrote Gawk to implement the new AWK. Since then, Gawk has gained a number of features. For example, it's gained functions for working with time, like stirf time. It's also gained support for arbitrary precision arithmetic. AWK uses doubles, so at a certain point you start losing precision and you start getting the incorrect numbers. So if you are using Gawk heavily for large numbers, you may want to use Gawk with -m. It's also introduced a lot of bit manipulation functions for shifting and performing bitwise arithmetic. And they introduced the next file keyword. So in AWK, you can write next to move on to the next line. And next file allows you to type next file and leave the current file that you're processing and head on to the next one provided on the command line. This was added to POSIX in 2012 and is available in Brian Kernighan's AWK and several other implementations. Beyond Brian Kernighan's AWK and Gawk, there have been several other interesting developments. There's mock, which is a bytecode version. It will compile your AWK down into a bytecode and then interpret it. There's also libmock, which is a form of mock that's been made suitable for using in a library in case you want to have embedded AWK scripts. And that is AWK today.